Greetings, math enthusiasts! Congratulations for making it until the fourth quarter. The measures of position of ungrouped data is our fifth and final lesson for grade 10 mathematics. Once again, I am MG Royo, your master in service. Before we finally say our farewells, are you ready to embark on this mathematical journey with me? Then let's ace the world of numbers together. Previously, we have discussed group data and how to solve for quartiles, deciles, and percentiles. To differentiate it with our current lesson, we define group data as data that has been organized into groups known as classes or categories. This is often done to simplify analysis and make patterns more noticeable. Moreover, it is presented in the form of frequency distributions or histograms. For example, the test scores of students might be grouped into ranges: 60 to 69, 70 to 79, 80 to 89, 90 to 100, with corresponding frequencies for each range. On the other hand, ungrouped data is raw data collected in its original form. It is not categorized or divided into groups. It is typically presented as a list of individual observations. For example, the test scores of students in a class: 78, 82, 95, 67, 88, and so on. The measures of position is a number that tells where the score stands relative to the others in a set of data. It is a measure whether a value is about the average or whether it is unusually high or low. In measures of position of ungrouped data, we can use different methods: the general method, linear interpolation, and Mendenhall and Sinsich method. However, let us stick to using the general method throughout this video lesson. Let's explore the quartiles of ungrouped data. Quartiles are the values that divide a dataset into 4 equal parts. From the figure, we can observe that 25% of the data falls below the first quartile, 50% falls below the second quartile, also known as the median, and 75% falls below the third quartile. Let's examine an example. The owner of a coffee shop recorded the number of customers who came into his cafe each hour in a day. The results were 14, 10, 12, 9, 17, 5, 8, 9, 14, 10, and 11. We need to find the lower quartile and the upper quartile of this data. First, we must arrange the scores in ascending order. Since 11 is an odd number, the median or second quartile is the middle value of the ordered data set, which is 10. This divides the data into 2 halves: the lower half, which is 5, 8, 9, 9, 10, and the upper half, which is 11, 12, 14, 14, 17. To find the lower quartile, we take the median of the lower half. The middle value of the lower half is 9, so quartile 1 is equal to 9. To find the upper quartile, we take the median of the upper half. The middle value of the upper half is 14, so quartile 3 is equal to 14. Therefore, the lower quartile is 9 and the upper quartile is 14. On a side note, there are cases where we encounter 2 middle values, which happen if the given data is an even number. To solve that, we only have to add the 2 middle values and divide it by 2. Let's move on to solving for deciles of ungrouped data. Deciles are the score points that divide a distribution into 10 equal parts, and the 5th decile is the median. The formula we use is d sub k equals k times n over 10, where k is the decile position and n is the total number of scores. Note that if the quotient obtained is not a whole number, round up to the next whole number. For this example, we need to find the 3rd decile of the following test scores from a random sample of 10 students: 35, 42, 40, 28, 15, 23, 33, 20, 18, and 28. First, we arrange the scores in ascending order. Now, using the formula d sub k equals k times n over 10, with k equals 3 and n equals 10, we calculate d3 equals 3 times 10 over 10 equals 3. The quotient is a whole number, so the third decile corresponds to the value at the third position in the sorted list. Therefore, the third decile of the test scores is 20. Let's solve for percentiles of ungrouped data. Percentiles are score points that divide a distribution into 100 equal parts, with the 50th percentile representing the median. The formula we will use is P sub k equals k times n over 100. Consider this example. The following list shows the number of bottles of strawberry jam sold in a day by 14 different vendors: 20, 18, 16, 10, 12, 15, 13, 9, 11, 16, 15, 16, 18, and 20. We will solve for the 43rd percentile. First, arrange the data in ascending order. Using the formula P sub k equals k times n over 100, with k equals 43 and n equals 14, we calculate P sub 43 equals 43 times 14 over 100 equals 6.02. Since P sub 43 is equal to 6.02, we round up to the next whole number, which is 7. Thus, the 43rd percentile corresponds to the 7th value in the ordered list, which is 15. Well done, learners! Congratulations on mastering how to solve for quartiles, deciles, and percentiles of ungrouped data. Your dedication and persistence have paid off. Thank you for your unwavering support of this channel. Once again, this is MJ Royo, your master, signing off.